Hi students everywhere. I am presenting for you solutions and discussion for physics past paper in IGC curriculum. I hope that it will be helpful for you. And this is the number of the paper 1, October-November 2017, questions 21 to 30. Now question 21. The diagram shows a ray of light in a glass. The ray reaches a boundary with air. One weak ray of light is missing from the diagram. Which statement is correct? I'll give you about 10 seconds to try to answer the question. At this point, there is a weak ray reflected inside the glass. So this is the right choice. The missing ray is a weak reflected ray. Like this. Of course, the angle of incidence here equals the angle of reflection. 22. Light enters a transparent block. The light is refracted into the block and then strikes the top edge of the block at the critical angle. Which diagram correctly shows the angle of refraction R and the critical angle C? This is right for the critical angle. This is the critical angle because the critical angle is the angle of incidence for which the angle of refraction equals 90 degrees. So the angle of refraction here is 90 degrees, and this is the angle of the critical angle. But the position of this R is wrong. It must be here. So the angle, this is the angle of incident in air, and this is the angle of refraction in a glass. So this is the right. C is the right. '23. Which statement about radio waves is correct? They have the same speed in vacuum as ultraviolet waves because all types of electromagnetic waves has the same speed, which is the speed of light. '24. Which types of thermal energy transfer are due to electromagnetic waves? Radiation. Radiation only. '25. The speed of sound in air is 330 meters per second. The speed of ultraviolet waves in air is 300 million meters per second, or 3 times 10 to 8 meters per second. This is the speed of light, which row gives a possible frequency and speed of an ultrasound wave in air. Ultrasound waves has a higher frequency than the upper audible limit of a human hearing, which is 20,000 hertz. So it must be this choice or this. Of course, the speed not equal to the speed of light. It remains the same. Speed of sound remains the same, 330 in air. So this is the right choice. Its frequency is 40,000, which is above the upper audible limit of a human hearing. The diagram shows the Earth and its surroundings, through which labeled region can sound not be transmitted. A. Seawater. B. Land rock. C. Atmosphere air. And D. Outer space vacuum. Of course, sound can propagate through a medium such as air, water, solids, as longitudinal waves. But it couldn't be transmitted in outer space or vacuum. So this is D is the right choice. "27. A train of steel nails and a train of iron nails hang from a strong magnet. The trains are then carefully removed from the magnet. What happens to the trains? Both the trains fall apart, both the trains stay together, only the train of iron nails falls apart, only the train of steel nails fall apart. Iron gets magnetized faster, but loses its magnetism as soon as the inducing magnet is removed. Steel remains magnetized for a long time. So this is the right one. Only the train of iron nails fall apart. The diagram shows an electromagnet. Which material is part X made from? The same reasoning for the for the last question for this, the same reasoning. That is, iron doesn't keep the magnetism. It loses its as the magnetism removed from. So iron is the right. This X must be made of iron, because iron gets magnetized faster but loses its magnetism as soon as the induced magnetism is removed. (29) In which unit is electromotive force EMF of a battery measured? A means ampere, G joule, N Newton, V volt. Ampere is for the current, joule is for the energy, N Newton is for the force, so V volt is for the electromotive force. Last question in this video. The diagram shows a circuit symbol for a component that can be used as an input transducer. Which graph shows how the resistance of the component varies with its intended input variable? Here, temperature versus resistance, and here the light intensity versus resistance, light intensity versus resistance. This is called LDR, light dependent resistor. It is a type of variable resistance whose resistance depends on the amount of light falling on it. So as the amount of light falling increases, so the resistance decreases. See here, as light intensity increases, the resistance fall down, and not in a linear way. So this is the right choice, C. Thank you very much, and I will complete the rest of the questions from 31 to 40 in the coming video. Bye-bye.